And the y-intercept is what I would call the key characteristic of when it's in standard form. So down here, you see it says standard form. In general, quadratics are ax squared plus bx plus c. Haven't we seen that when we use quad formula? Okay, this c, that is going to give you the y-intercept. So when something is in standard form, I know a couple things about the graph, okay? First of all, I know if a is positive. What does that tell you about the graph? Remember? It opens up. Good, Alex. And if a is negative, it opens down. So I would know that, and then I would know the y-intercept. Just right away, without doing any work, I would know those things. Okay, what if I wanted to find the vertex? Well, then we use this formula, negative b over 2a, and we can do an example of that in a minute. And that gives us the axis of symmetry. The axis of symmetry is this vertical line. What does it do to the parabola? Does it look like? Just splits it in half, okay? And it's like a reflection line. Symmetry means it has some kind of either reflection symmetry or rotation symmetry. If I would flip that parabola over, it would map right onto the other side. We did this in algebra, but to find the other coordinate for the vertex, all you do is you plug your x coordinate in for x in the equation and you find y. All right, x-intercepts. The x-intercepts, well, first of all, in this form, we learned, didn't we learn this last unit? What are the ways you could find the zeros or x-intercepts? We have quadratic formula, but what else did I do on your text? I gave you a quadratic. What did you do with it, hopefully? Factored it. You can factor it, too. If it's not factorable, though, you have to use quadratic formula. Okay, next. Vertex form. So in vertex form, I'm going to highlight this. Do you see that A still there? I still know if it opens up or down, but in vertex form, guess what you can find? The vertex. So the vertex is just going to be this H and K. So today we're going to work on how do I get from standard form to vertex form, and then also to factored form. How do you find the x-intercepts? Well, you would see how there's an x minus h squared there. You would want to expand that, multiply it out, and then use factoring or quadratic formula to do that. Probably the least familiar. Who had algebra here at the high school? You did. You did. I only say that because I know I talked about in algebra class, is we also have this form called factored form. And when something's in factored form, we were just doing this last chapter, that finds the zeros, but the zeros are also the x-intercepts. So factored form, I don't know if I'm going to like this highlighter. I think it's kind of dark. Factored form is going to give us the x-intercepts. Okay, so looking up here, whatever this R1 is, that's one of the x-intercepts. So R1, 0, and R2, 0 would be your second one. What are ways you could find the vertex from there? I'll give you options. I like options. You like options, but I like options. Look up at the graph. What do you notice about the vertex in relationship to the x-intercepts? Yeah, is it halfway in between? So if you wanted to find the vertex, what you could do is you could just find the midpoint, so average those x-intercepts together and go halfway in between, and then plug it in. Okay, so this is a nice summary of all of the different forms. Let's see what we have back here. Ooh, we have an example for you to look at. And then I'd like to do one more. Okay. Here's standard form. What do we know? We know the y-intercept. They go through finding the axis. Negative b, that's negative 4, over 2 times a, so 2 times 2. And then they get negative 4 divided by negative 4, which is negative 1. They plug it in and so on. All right, what does it look like we're doing here to find the x-intercept? What's that look like? Yeah, they did quadratic formula. So after they found all those things, then they had a picture of the graph. All right, so what's in your notebook? So let's get your notebook out, please. Let's do an example. Of finding something in rearranging it to vertex form. So it's a T. So let's say f of x equals 3 times x minus 1 times x plus 5. What we're going to do is find the standard form and vertex form. And then we're going to draw a picture of the graph. Okay. Who can tell me which form is this? You can use this one. Factored. So, if it's factored form, what does that tell me? What do I know? Good. I know it opens up because of that 3, and I know the x-intercepts. The x-intercepts are the zeros of this. If I set this equal to 0, one of the x-intercepts would be 1, 0. And the other one would be negative 5, 0. Okay, any questions on that? Okay, pretty easy to standard form. All you're going to do is you're going to multiply this out. When you're doing that, you're going to want to multiply these two binomials and then distribute the 3 last. That's the one, I would say, the way that gives you the least errors. So let's do it. So I'm going to put that 3 on the outside. And let's see. What's x times x? X squared plus 5x minus 1x minus 5. Normally after a while, I don't even write these middle two. I just do them in my head. And you may do them in your head as well. 5x minus 1x is just 4x, right? Okay, last step. Let's distribute out the 3. Okay. So now I know the x-intercepts. Why? Because the factored form told me that. What does this tell me? Now what else do I know on the graph? The y-intercept. So in a second when I graph it, I'm going to know the y-intercept. The y-intercept is 0, negative 15. And by the way, guys, if you want to find the y-intercept up here, you could always plug 0 in for x. You would get the same thing. You'd get 3 times negative 1 times 5, because the y-intercept is when x is 0. Okay. Bless you. All right, last thing. What do I need to find? I did standard form to vertex form. All right, so there's a lot of ways to get to vertex form. Oh my goodness. I'm wondering how many I should teach you. Have you heard of completing the square?
Yeah.
Okay. That's probably the most complicated way. At the end, I'll show it to you if you want, for my mathematicians in here, if you want a challenge. I want to practice using the formula negative b over 2a, only because I think that's a little more complicated, but I'll also show you how you can average those two together. Okay. So I am going to find the axis. The axis is the same thing as the x-coordinate of the vertex because it goes through that. And I'm going to do the opposite of b over 2a. Looking at your equation above, what would be the opposite of b? Negative 12. 2 times a is 2 times 3, which is 6, right? And negative 12 divided by 6 is negative 2. So I know the x-coordinate of my vertex is negative 2. To find my y-coordinate, I find f of negative 2. All that means is I plug negative 2 in for x up here. Oh boy, I'm going to try this in my head, but you guys can, if you want, you can use your calculator. Oops. That's what I meant. Can somebody check my math for me a minute? You got something? What? Negative what? So you're telling me I'm wrong? What did I do? Oh, I did pause. No, I don't even know. I don't know. I'm crazy. That's why I have you check me out. Negative 27. All right, thank you. Yes, it is. Negative 12 minus 15 is negative 27. All right. So what would be the vertex form? I am going to just plug that in for my vertex, and I make sure I take my a from above. The vertex form would be f of x equals 3, parentheses, x minus h. X minus h would be x plus 2 squared minus 27. That's its vertex form. Okay, let's just then sketch a picture of what that graph looks like. If I put all those things together, what I would start with is I would start with your vertex. That's the low point of the graph. And we're going down to negative 27, so it's going to be a sketch. I'm going to go down maybe a scale of 5, 5, 10, 25, 30. I'm going to do a scale of 1s here. All right. So the vertex was negative 2, negative 27. So I would have negative 2 and negative 27 is right around here. What were the x-intercepts again? Do you remember? Was it 1 and negative 5? Yeah. Okay. So let's put those on there. And then I would want to make sure that it passed through the y-intercept. The y-intercept was negative 15. And then I'll use just a smooth curve through those points. That's not a bad looking parabola. Okay.